Hi, I'm James Nicodemus. In today's demonstration we're going to show how you can make a balloon fireproof. And obviously a balloon is not fireproof on its own. What I have here, we'll start with, is a regular latex balloon. And this one's just filled with air. So we're going to hold this right over the sink here, and then I am going to take this lighter, this big lighter here, and we're going to show what happens when you put a flame to a regular balloon. It pops. Okay. Our second part here, I'm going to take this balloon, and the bottom of it, as you can see, is full of water here. Alright, now I'm going to take our same lighter here, and we'll go, and we can see that this balloon is not popping as long as we put that flame under it. It is not going to pop. So this one is flame proof. I have another balloon here, and this one is completely full of water. There's no air on the top of this one. Anywhere we go on this balloon, it appears to be remaining fireproof. And we'll go back to our original balloon here in just a minute. As we can see on this balloon, the bottom of it, you can see the little bit of carbon deposit on the bottom. The bottom of this balloon is, in fact, filled with water and does not pop. We'll take this. That's what happens when we have when we get towards the air part, and then the balloon pops here. In the second part of our demonstration, we're going to show why this is the case. All right, thank you very much.
So when we talk about the latex, what we have here, we have a latex balloon that's full of air. And a butane flame, this is somewhat approximate here, but in the neighborhood of about 1400 to 1500 degrees Fahrenheit, very hot. And latex melts in the neighborhood of 250 to 350. So if you have a balloon full of air under pressure, we put the flame to it, and obviously it popped in our demonstration there. So air, we found, is a rather low density, 1.225 kilograms per cubic meter, and has a specific heat of 0.718 kilojoules per kilogram of Kelvin. So the air balloon popped when we touched it. When we have a balloon with water on the bottom and air on the top, water has a much higher specific heat of 4.186 joules per gram, and is much more dense than the air was. So the water is able, there's many more molecules tightly packed together here with a much higher degree of heat capacity. So the flame passes, the heat passes through the latex and is absorbed by the water, and which allows the latex to stay cool and not melt. When we moved it up closer to here, where there was just air and not water, then the heat from the flame melted the latex, and next thing you knew, the balloon pops right open. So the bottom line is that air is about 784 times less dense than water, and water's specific heat is over 4 times that of air. So if we took the volumetric heat capacity, if we said what is the specific heat times the amount of density more that water is, it's, you know, our with to do with humidity and pressure and that, but certainly a very, very large amount of times that the water has over the air in absorbing the heat. So once we get, it doesn't take a lot of heat, obviously, to melt the latex, and we have a flame that's many times stronger or many times hotter than would normally melt a balloon. So in order for the latex to stay cool, the flame sits underneath the water pulls the heat off the latex, and it never gets hot enough to melt. Obviously, when we move that up and touch it to the part that has air, well, then we get an explosion and a big mess. So now you know how to make a flame-proof balloon. Thank you very much.